In this video, we are going to see the volume of distribution. So, its definition could be better understood if we see some examples. So, consider a beaker which is filled with water. We don't know the volume of liquid which is present in this beaker. Okay. Now, we are going to weigh certain amount of drug, say it is 1000 mg of drug, and we are going to dissolve the drug in this beaker completely. So, let us find the concentration of the drug which is present in this beaker. So, concentration came to be 100 mg of drug is diluted per liter of the liquid. Okay. So, concentration equals to weight by volume, because we can see concentration is always denoted by weight by volume, mg by liter. Okay. So, let us shift this volume to the left hand side. So, volume equals to weight by concentration. We already know the weight of the drug is 1000 mg and concentration is 100 mg of drug is present per liter of the liquid. When you divide this 100 by 1000 by 100, it equals to 10 liters. So, the volume of liquid which is present in this beaker is 10 liters. So, the 1000 mg of drug is diluted in this 10 liters. So, in the same beaker, let us put a fish inside this beaker. Volume of the beaker remains same, weight of the drug remains same. Let us find the concentration of the drug. So, concentration came to be 50 mg per liter. So, in the previous beaker it was 100 mg per liter, but here concentration has dropped down to 50 mg per liter. Okay, the reason might be the fish. So, the fish is eating up the drug. So, the concentration of the drug which is present in the beaker has fallen down. Okay, now let us find the volume of distribution. So, volume of distribution we know it is the weight by concentration. Weight of the drug is 1000 mg, concentration of the drug is 50 mg by liter. So, volume of distribution is equal to 20 liters, but the actual volume of the beaker was 10 liters. Just adding the extra fish, as the drug was going into its mouth, the volume of distribution has raised it from 10 liters to 20 liters. So, the volume of distribution, which is also called as apparent volume of distribution, can be explained or defined as follows. It is not the real volume of fluid, it is the theoretical volume of fluid in which the total drug administered would have to be diluted to produce the concentration in the plasma. So, to produce certain concentration in the plasma, the volume has to be diluted to a particular amount. So, in this other beaker, just replace the fish with the extravascular components like brain, lungs, kidney. So, the volume of drug from the plasma goes into these tissues. So, the weight of the drug remains the same, weigh 1000 mg of the drug, and we are injecting it through IV route, and after it reaches some steady state concentration, find out the concentration of the drug in the plasma. Concentration came to be 20 mg per liter. So, let us find out the volume of distribution. It equals to 1000 mg of drug, which is the weight, and divided by concentration of the drug in the plasma after it reaches the steady state, which is 20 mg by liter. So, volume of distribution is 50 liters. So, why are we finding the volume of distribution? It has nothing to do with the actual volume of body or its fluid compartments. So, we are not finding it to see how much amount of volume of fluid is present in the body compartments or its fluid. It is used to find the distribution of the drug within the body. So, if the volume of distribution is low, it means that more amount of drug is present in the plasma. Concentration of the drug is present more in the plasma. And if the volume of distribution is more, it tells that the drug is leaving the plasma and it is entering into the extravascular components. So, consider different body compartments: plasma, the other compartments are fat, the other compartment is brain, lungs, kidneys, or any other tissues. So, if the plasma concentration of the drug is more, volume of distribution will be less, which means that for a drug which is more protein bound, plasma protein bound, more amount of drug will be present in the plasma and it will not be moved to the other body compartments. And for the drugs which are more tissue bound, so the plasma concentration of the drug will be less and the more amount of drug will be concentrated in the other tissues. So, for a drug that is highly tissue bound, very little drug remains in the circulation, thus plasma concentration is low and volume of distribution is high. And for the drugs which tend to remain more in the circulation, they tend to have a low volume of distribution. So, these are some of the examples. Acidic drugs like warfarin and aspirin, they tend to have a very small apparent volume of distribution because they are highly plasma protein bound. And basic drugs like amphetamine and meperidine, they are extensively taken up by the tissues. So, less amount of drug remains in the circulation, so they have more apparent volume of distribution. So, apparent volume of distribution tells us about how extensively it is moved into the tissues or it remains in the plasma.